Hey guys, I know your calendar says that we will do problem set 110 and 111 today, which is Thursday, but that's actually not true. We're going to do both lessons. Like I'm going to teach both lessons, but you're actually just going to do one problem set. So I'll tell you that at the end exactly which problems to do, but don't worry, you're not going to have to do two problem sets today. So today we're talking about circles, and then we're going to talk about circle graphs in the next lesson. So I thought they kind of went together. And this first lesson, lesson 110, is kind of a review of what we did on Pi Day. So I just kind of wanted to review that basically for you, just so you could kind of remember what we did that day. I know that was the last day I saw you guys all together in class, so but hopefully you remember a little bit of what we learned. So let's go ahead and read this paragraph. Many of the words we use in math are based on Latin or Greek words, and I believe in 5th grade you're going to do some Latin and Greek study words for your vocabulary. So a lot of our words come from those roots, but the Latin word for ring is circus. And you might have recognized that word from a circus. You know, like you have a 3-ring circus, or the circus is performing like in a big open circle. So those words kind of all relate to each other. The Latin word for the spoke of a wheel is a radius. So you might see like it looks like spokes, like of a bicycle wheel or something, or a wagon wheel. And then the Latin word for through measure is diametron, or diametron. So circus is where we get the word circle, and then radius is where we get the word radius, which is a line from the center of the circle, or a line segment technically, from the center of the circle to any outside edge. So you'll see, and the plural is radii, but all of these radii would be the same measurement. They would measure the same because they're all equal distance from the center to the edge. So anywhere you draw a line from the center to the edge is a radius. So that's where we get that word, because it means the spoke of a wheel. And then the diametron, or diametron, is the distance across, like all the way across. So if you go straight from one side to the other through the center, you will find the diameter, that's where we get the word, of a circle. So all the way across, and it could be from top to bottom, it could be across, anyway. Any direction you go, as long as it goes straight through the circle, then it is a diameter. And so down here, then it shows you the English words. From these Latin words, we get the English words: circus, circle; radius, radius; diametron, diameter. I'm not sure if I'm saying that correctly. But anyway, so that's where those words come from. And if you'll notice, a diameter is twice as long as a radius, because the radius goes from the center to the edge. The diameter goes from edge to center and then center to edge. So it's like 2 radii, which is, like I said, the plural of a radius. So here's a radius, add them together, and you get the diameter, which is all the way across. So let's look at the example. The diameter of this circle is 4 centimeters. What is its radius? Well, you know that if it goes all the way across and through the center, this is 4 centimeters. So if you put a center dot there and you have half and half, what would the radius be? Half of 4 is 2. So you basically just cut the diameter in half to get the radius. And then if you had, like, let's say you had only the radius and it was 2 centimeters, you would just double it to get the diameter. So as long as you have one or the other, you can figure them out. Then in the practice, let's just read these together, and you just kind of say them to yourself. What is the name for the distance across the center of a circle? Like this, all the way across the center. Remember, it starts with the D. diameter. Okay, then what is the name for the distance from the center to the edge of the circle? So let's say we had this just from the center, that is the radius. And then C is kind of like the problem I was giving you a second ago. If the radius of a circle is 4 centimeters, so here's a radius. If that was 4, and then we put another radius over here to make the diameter, what would the diameter be? If you double the radius, you get 8, right? So C is 8 centimeters. Okay, and then you can just skip all of problem set 110. Now, if you want to go down and look at number 7 just as a practice, you're welcome to do that. Well, you're welcome to look over any of them, but you don't have to do any problems from that. So then lesson 111 is circle graphs. And this is pretty easy concept. We've studied pictographs, bar graphs, line graphs. Well, another kind of graph is a circle graph, or it's also called a pie graph because the pieces or the sections of it look kind of like pieces of pie. So the first example says, use the information in this circle graph to answer these questions. So it has a title. A graph should always have a title. Activities of 100 children at the park. And then you'll see the activities are listed and the number of children participating is listed. So A, how many children are there altogether? Well, we could add all these numbers up, but the quick way is look at the title, 100 children. Which activity were most children doing? Well, you can look at the numbers, but you can also find the biggest piece of pie, which would be 20. And since these are similar, you want to check the numbers just to make sure, but 20 were flying kites. That's the most. How many children were not catching pollywogs? Well, if 19 were catching pollywogs, like Izzy has been doing in her pond or lake behind her house, how would we figure out all of these? Well, we could add all these together, but then you notice we have other. We'd still have to figure out what that was. But we could say the total, 100, minus 19 would give us the answer. Okay, so in your head, you could probably do 100 minus 20 would be 80, and then minus one more, because this is one less than 20. Or you could write it out, 100 minus 19, and you would get 81. So how many children not catching pollywogs would be 81. And then on the back page, it shows you, it walks you through the solution. So you can read over that if you need to. Then there's a practice here. Use the same graph. How many children were either hiking or skating? So you'd go back and look at hiking and skating, and you would add those together. 12 plus 15 is 27. So 27 children were either hiking or skating. Then how many more children were flying kites than catching pollywogs? So we're going to compare those two. Flying kites is 20, catching pollywogs is 19. So how many more were flying kites? 1. And then C, what number should be in the section named Other? So this is what we were talking about a while ago. So we'd have to add all of these together. So let's do that really quickly. We know that 12 plus 18 is 30, right? 8 plus 2 is 10, plus the 2 tens there, that's 30. And 15 plus 15 is 30, so that's 60. Plus 20 is 80. Plus almost 20, 80 plus 19 would be 99. So other then would be 1. There's one child doing an other activity. And we don't know what they're doing. You could make up what they were doing. Maybe swinging or jumping rope or who knows. But The one child was just left out. Don't know why they did that other than to have you figure out the answer. So now you're going to work on problem set 111. And these are the problems that you're going to do. So not a whole lot of problems again. Again, I want you to keep working on your essay. So I'm trying to give you kind of a light load in your other subjects. And again, I wrote lesson 111, but it's problem set 111. Do all the word problems, number 1 through 13, and then 20, 24, and 28. So you can pause the screen if you want to write these down. So basically you're doing the word problems on these 2 pages. Then number 20 is multiplication, 24 is division, and 28 is drawing and shading circles to make fractions. So just giving you kind of one of each of those kind of problems. So this is the last problem set for this week. Tomorrow, Friday, is kind of a catch-up day. If you haven't finished your essay, you want to work on that tomorrow or as soon as you finish this math lesson. If you have finished your essay, then you can go back and just review or catch up anything you need to work on. Thanks, guys.